When I started preparing this week's class to record for you, I realized that a large section of it already exists on YouTube. It was the very first lecture I ever recorded, so it's old now. And as with all old things that live in a permanent place, it's kind of embarrassing for me. I wanted to revisit it and use the opportunity to correct a bunch of things I know are wrong with it. But then I rewatched it and realized the things that are wrong with it are mostly technical. The sound is terrible. It's a lot of separate soundtracks spliced together. The refrigerator comes on, the clock is chiming, there's an alarm in the background. But the thinking and the presentation are mostly accurate. The things that bothered me were my use of the historical present, which I don't like, in discussing the past, and some weird pretentious way I had of saying which and what, and I don't know where that came from or where it went. But in truth, the recording, in terms of its information, is actually better than I could do now. The information was newer in my brain and had been more recently knit together. So I've decided instead to record the extra content that isn't part of that I've developed since, that I think is really exciting and worth sharing with you. But I'm going to ask you to spool out of this video and watch that one, and then come back to this one and we'll finish the rest of the conversation. So what you're supposed to do is press pause on this, go watch that, and come back, and I'll see you on the other side. So either you went and watched an efficiency lecture and came back for more, or you're still watching and I don't know why. Either way, welcome back. There are a few images I want to show you that relate to that lecture that I found in the intervening years that answer some questions. Students asked every year about the hand light that the Gilbreths used. How big was it? Was it cumbersome? Did having a light strapped to your hand actually change your motion? So maybe their motion studies weren't quite as pure as they should have been. And I finally, 2 years ago, found this unicorn, this very beautiful clear picture of the Gilbreth hand light. So the answer, of course, is yes, that cord would have gotten in the way, but not so much that it would completely change someone's motion. And I suspect there were different ways to wire it and attach it. And I have to show you this image because any student in the sophomore year at RISD should know what's going on in this picture. This is a Gilbreth motion study. Go ahead, shout out loud what you think this is for. What is happening in this picture? Anyone who took Metals 1 last semester should recognize this as a drill press. So the operator reaches over. It's a right-handed operator. They reach across to get the control lever and pull it down. And then there's the lifting back up for chipping, for releasing the chips that are cut off. Down again, up again, all the way down through the metal or material, and then releasing. So that's the complete cycle of how to drill a hole in something. And the operator knew how hard to push, when to chip, how many times to release for chipping. And so anybody running their hands over this 3D model would get a better sense of the proper way to drill for that setup. I also wanted to show you this refrigerator, mostly just because it's so cute. Don't you want a round refrigerator? I do. But I wanted to point out that we think the devices we have today existed just inevitably because that's the way they're supposed to be. But it takes a long time to figure that out. When home refrigeration was still relatively new, Bosch produced this small cylindrical refrigerator. And you may think it's a silly shape for a refrigerator, but that's only because you grew up in a world where everything in a kitchen is a rectangle. But in the 1930s, especially in Europe, an inexpensive small refrigerator you could add to a room was the goal. And a cylinder out of metal uses the least amount of manufacturing. It's one piece of sheet metal just bent around. It also gives you even distribution of cold. So it's an efficient refrigerator. This is actually a really good design unless your design specification is that the refrigerator fit into your system of rectangles. So once the kitchen became a kit of parts, we knew that a drum was the wrong shape. But before that, why not? So here's the new content. I'm calling it From Scientific Management to Universal Design. It turns out that all of the thinking that went into understanding how to use our bodies for industry to be more productive transferred into the home to make using our home equipment easier. And that pursuit pretty directly leads to a better understanding of designing for all abilities, which is a really crucial part of good design work. Just to remind you, or for any of you naughty viewers who didn't go watch the other video, in 1900, kitchens were not designed. They were merely a room with some equipment. If you were lucky, you had a hot water heater. That's what the copper cylinder next to the stove is. But most kitchens were not designed with input from the people who used them. And this is what Christine Fredericks was responding to. This is not a landscape of smart use, of scientific exploration. It's not designed for the person who needs to make this kitchen work. Even when electricity entered the equation, it didn't really improve things much. This is an early installation of electricity, and this is a promotional picture, so it's showing how much better your life would be if your kitchen had a strip of plugs and you could plug in all these new devices. But these devices were not actually designed to be used in the kitchen. They were designed to be used at the dining table or the breakfast table to make coffee or waffles as a sort of novelty modern experience. In the rare instances when a kitchen was considered by a designer, it was usually as a show kitchen or an experimental installation or an architectural installation. This is a Peter Behrens kitchen, which is very beautiful, but also, if you look closely, starts to incorporate a lot of what many years later Christine Fredericks and Shuta Lahotsky with the Frankfurt kitchen were proposing. But this is a one-off, custom, one-time thing. The best most people with their average kitchens could hope for was a Hoosier cabinet, or some piece of furniture that centralized the activity and offered equipment in a convenient location. Because of Christine Fredericks' work, kitchen design started to be something that at least considered standard height counters, built-in drain boards, built-in storage, easy-to-clean surfaces, and at best also started to tip into including some aesthetic sensibilities. In the same spirit of the Peter Behrens design, there was a kitchen designed at the Bauhaus, on the campus of the Weimar Bauhaus in 1923 for the Haus am Horn. When we get to the Bauhaus next week, we'll see some of Marcel Breuer's furniture for this house. And you could describe this as a classic Bauhaus exploration of geometry, but you can also see in it a desire to have not only a machine aesthetic, but a machine sensibility about how the kitchen could work. All of the ceramics were produced with labels right on them, so you'd know what was inside. It is, of course, the Frankfurt kitchen that we use as the example of the ultimate combination of scientific management thinking and the domestic machinery. This is a kitchen that looked at the actual use through motion studies and reorganized the entire landscape of equipment to work better for the person using it. But that's usually where the conversation about the history of the kitchen sort of stops. Shuta Lahotsky is the one you always hear about because the conversation sort of went away, and there are a few reasons for that. The bending and stooping and reaching and lifting that was so frustrating to Christine Fredericks was mostly eliminated, partly through her work with science and study and better kitchen design, so we got standardized heights for things, but that led to conventions, which led to the ability to manufacture kitchens as a kit of parts. Also, World War II introduced new equipment to the kitchen, which changed the landscape completely. We got dishwashers and miracle stoves and freezers and fridges and easy care flooring and enameled metal surfaces. Also, almost everyone had electricity after World War II, which was not the case beforehand. So the kitchen started to be a manufactured system. Because there were conventions involved, because there were standardized heights, because appliances started to be standardized widths and sizes, companies could come in and start making them as a rationalized system of parts. And we even saw kitchen cabinet companies beginning to include women in the design process as designers, as co-creators, to make better cabinets that would address their needs. So kitchens started to become arrangements of standardized parts, and cabinets were ordered from cabinet companies instead of constructed by builders or carpenters. When you have builders and carpenters creating kitchens, each one is different. Each one is built in place. When you're buying prefabricated components, the architecture changes to accommodate them, and everything becomes standardized. So cabinets started to become an exercise in manufacturing, a system of boxes and doors. And they were sold more for fashion and decor than for function. We arrived at 36-inch height. It's not the right height for everyone, but it was close enough. It was an average, fine, done. Also, after the war, a lot of the manufacturers that had tooled up to make things out of metal for the war effort needed something to do with their equipment after. So we started to see metal kitchen cabinets produced in post-war factory settings. We also got new materials for cookware. Stainless steel and aluminum were much lighter, because aluminum is lighter, because stainless steel could be thinner, than the cast iron that Christine Fredericks was talking about. So one reason she was frustrated with the sink being so low is that the sink had to be low. If you had a huge cast iron pot that you had to fill with water, you couldn't lift that up to put into a high sink. The sink had to be at a low level so that you could use your body strength to move a very heavy pot full of water. When that pot is out of the equation, the sink can be raised up to a height that suits the body better. And so the natural evolution of design led to us mistakenly thinking we had solved the problem and then forgetting there was a problem. We started to not care if something was convenient because it was beautiful. If it's turquoise, it works, because I look great standing in front of my turquoise kitchen in my coral cocktail dress. And in the distance, you can see my matching coral-colored laundry room. And when the equation changes to fashion and style, function disappears from the conversation. So all of the ads for kitchens from the 50s on are talking about color or pattern or style or arrangement opportunities. Maybe they're talking about ease of cleaning. But you can see in these kitchens, ease of cleaning is not the concern. It's the crazy range of options and patterns. But I don't want to leave the conversation about kitchen design there. I want to shift gears because this story of kitchen development provides a really neat opportunity to examine the development of universal design. So let's pause and look at that. The stories are related. Kitchen design at the time was not concerned with designing for all body sizes. If you were short and a 36-inch counter height was bad for you, too bad, get a stepladder. There just was no consideration for variety of user size. That is the foundational importance of universal design. Objects should be designed so they work for everyone. You shouldn't have to change who you are to use an object if it's well designed. I want to talk about Thomas Lamb, who was an important voice in the development of universal design. As a teen, he apprenticed with a plastic surgeon, not something I would have done as a teen or now. And he traded medical drawings in exchange for anatomy lessons. And then he was working at the time at a textile design shop. He studied art at the Art Students League in New York and merchandising at Columbia University. And that's the sort of magic combination for him. There's an understanding of anatomy and medicine, plus art and design, plus commerce. It's a potent combination in this case, and that helps define Thomas Lamb's career. After World War II, he noticed veterans having trouble using the Army-issued crutches, and he started to examine the way crutches interacted with the body. And he noticed that the hands bore the main burden. And so he started experimenting not only with a new shape for under the arm, but completely new approach to the handles to redistribute the body's weight onto the wrists. The study of the hand's dynamics and anatomy in relation to use led to an understanding of the thumb and forefinger's relationship to the other fingers in controlling weight distribution and movement. After extensive work, he developed his Lamb Limb Rest Crutch. I had to record that 4 times before I could say it right. This is a really interesting design because, one, he also looked at how people were on crutches for a while and then switched to a cane, and that's extra equipment, and sometimes you need to switch back. This is everything in one. This is an ambidextrous design, so you just need one for both sides. It works as a crutch, and when you're ready for a cane, you uncouple the 2 parts, and you have 2 canes or 1 cane. So it's a whole system for the entire recovery period. The crutch was promoted by Macy's and at Macy's, and this is a promotional brochure for that. But it didn't arrive at great commercial success. In spite of that, it did open the door to an entire career investigating, improving, and applying better handle designs to manufactured objects. Lamb wrote, "The hand is the supreme compilation of mechanical cables, springs, levers, webbing, sheathing, rigid braces, ball and socket joints, hinges, pads, cushions, and interlacing overall upholstery." He also said, "The hand is the most perfect and versatile tool, the miraculous machine with which man has become the world's master and to which civilization largely owes its existence." He developed his limb rest thinking, and I have this slide just to show you the remarkable range of explorations. The loose drawings are so beautiful. He was a really, really adept draftsman. The tighter hand drawings are showing a next level of information and detail. The technical drawings are extraordinarily specific and detailed investigations of geometry and its relationship to organic form. And then the tight finished documents need to communicate shapes that, frankly, by their very nature, sort of resist being communicated on paper. The patents that came out of the limb rest crutch provided the foundation for his entire career, and licensing those patents to different manufacturers allowed the innovations in them to affect many other industries as they were added to cookware and cutlery and surgical tools and razors, housewares, sporting equipment. There's a welding torch handle as well. You name it, they're everywhere. I have a bunch of pictures from his archive, and I'm showing them to you because I think they also show process so beautifully. Screwdriver and razor on the left, and those are carved wooden models with notations on them for the refinement of the form. Because remember, there was no CAD, there was no 3D printing. That doesn't mean there wasn't the ability to arrive at sophisticated and functional shapes. And the drawings on the right show the extension of these forms onto above surgical tools. Below, there's the proposal for everything you could ever attach to a pole or a rod to get better grip on it. In the end, there were two different designs, the wedge lock and the universal handle. The wedge lock handle, in his description, wedges the fingers apart and locks the thumb and the fingers in place. So in understanding the relationship of the forefinger and the thumb to the rest of the hand, he realized that if you made a handle that positioned those in particular ways, you could increase the ability of the hand to do something. By the late 1940s, Thomas Lamb was known as the Handle Man. The MoMA had an exhibition in 1948 called the Lamb Wedge Lock Handle, and these are pictures from their archive of the installation. I also just think this is a fascinating glimpse into what museum exhibitions look like in 1948. You won't be seeing an exhibition that looks like that at the MoMA today. The most commercially successful application of Lamb's wedge lock handle was, and still is, the Cutco knife. It was introduced in 1952. The company had started in 1949, but really didn't find the success that we know them for until they added the Lamb handle. These knives are still produced today. The handle is largely unchanged, and it's a rare example of a design enduring through decades of change in style and manufacturing and material interests. Lamb's work is usually cited as the beginning of the universal design movement. His interest in designing for every hand to make hands work better extended to the larger idea that all design should be better for all people. Mark Harrison was a long-term professor in the industrial design department at Rhode. There is an article about him next to the elevator on the 6th floor that you can read, and there used to be a whole wall of photographs of his work professionally on his own and with students across from that, but those have all been removed and have been left lying about in random places. So if you hunt around on the 6th floor, you can find some really important photographs behind the sink and next to the microwave, and I think you should do that before they disappear. Harrison sought out Lamb in the mid-60s because he was aware of his work and wanted to learn more about it, and they developed a lasting friendship, with Harrison becoming a student of Lamb's work. In the eulogy that Mark Harrison delivered at Lamb's funeral, he said, "At that first meeting, Tom demonstrated the magical qualities of his remarkable handle designs, demonstrations so powerful as to leave me in disbelief and true wonder. My head ached, attempting to absorb the torrent of ideas Tom expounded about, the anatomical and mystical qualities of the human hand, and the inspiring discoveries he had made, all of which was delivered with evangelical enthusiasm and passion. I don't know about you, but if someone described meeting me that way, my work here would be done." Mark brought the thinking back to RISD in his teaching and also into his professional work. He's most remembered for his complete redesign of the Cuisinart. Cuisinart was an American kitchen appliance that was developed from an imported French device called the RoboCoupe. The RoboCoupe had been invented by a French caterer in 1960 and was really designed for professional kitchens. It was a big motor and a spinning blade, and it made food preparation easier, but it was very expensive. Nevertheless, when imported to America, it helped introduce home cooks to some of the techniques that had only been available to professionals, and it was very successful. When the import agreement ran out, Cuisinart had an opportunity to re-examine this device and redesign it, and they hired Mark as a designer. The differences are astounding, and I hope that's visible to you without even a description. On the left, there's a motor at the bottom with vents in the front. There's a terrible script label to suggest that it's really French. And there are a bunch of things functionally that don't really work very well. There's no handle on the container. You have to grip the whole thing. And there's a cylinder in front that has the safety mechanism so that it won't operate without the lid on, but none of those parts has been considered in terms of use. Mark's design on the right is a triumph of smart design decisions disappearing into something that just seems like a beautiful object. The motor's still in the base, but now the base is elevated on a pedestal, a black area that has all the venting, so the heat goes out underneath. The on-off buttons are levers, so that you can hit them with your messy hand, with food on your hand. You could hit them with your elbow, you could hit them with your fist. It also allows for any size hand, any ability hand to turn this on and off. The added handle has a large grip, so it can be gripped well by small hands or large hands or arthritic hands. The chute for the food has been moved to the back because they found that people would look down and you peer down the chute, and putting it in front was a bad spot for it. Also, that's been turned into an easy grip oval, so you can grasp it to rotate and open the top. So all the things that contribute to the aesthetics of this are actually really smart steps forward in making a device that's easy to clean, easy to operate, and also sold extremely well. The design may seem inevitable, but in good design process, there are many, many iterations and investigations. These are two drawings of what the Cuisinart might have looked like, and they're not the right answer. And we see that very clearly because we know what the right answer was, but at the time these were close enough to a good answer that they were drawn up as finished drawings. That process, that design process of constant iteration, full-scale models, multiple variants, reassessed and recombined, is something that Mark Harrison introduced to design education at RISD, and frankly it was one of the reasons we didn't get along too well, because I was not his idea of a thorough design student. What isn't scattered around on the 6th floor of the design building at RISD is now safely in the Hagley Archive in Delaware. So that was Mark's professional work, but in his work teaching, he instituted a series of studios that produced some really remarkable work that helped bring his ideas and Thomas Lamb's ideas about universal design back into the kitchen and create a neat loop for our story today. I want to tell you about the Universal Kitchen Project, which was a 5-year project with industry support from Cole and Frigidaire and Maytag. The first step in this multi-studio, interdisciplinary, multi-year project was research. The designers made a dinner repeatedly in typical kitchens and studied the motions. The dinner was a very simple one. It was spaghetti with salad and bread. And they realized that there were more than 400 discrete steps in making just that simple dinner. And in each kitchen, they charted those motions to start to understand the patterns. They also realized in observing home chefs that short people and tall people did things differently, that old people had strange inherited behaviors that were still part of how they used their kitchen. So there was a very short woman who insisted on getting her colander out from above the refrigerator with a stepladder. She had many more motions than everyone else, and that's just where her colander had always lived. I also think I did not make as clear as I should have in the efficiency video the difference between a time and a motion study. And most design students say things like, I did a time and motion study. And they don't mean that they did that. They did a motion study, or they did a time study. This is a motion study. We don't know how time is passing in this. It merely shows where people went to do things. So the design process started reimagining the kitchen, relocating objects, and they did this in real time in full scale. Build full-scale cardboard models to test the theories. That's really rare in design education anymore because everybody lives on their laptop and nobody wants to go to studio, and why would I cut out a piece of cardboard if I could 3D print, and blah, 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 everything you ever said to me, and I rolled my eyes. I know what some of you are thinking. This is what Metals 1 was. Try it, revise it, assess it, try it again, circular iteration, endless loops to get somewhere good. And many of you resisted that, and some of you embraced it. Hopefully the experience of the class in Metals 1 helps you understand design process as something that is inherently, in a healthy way, iterative. And if you're thorough about that exploration, you will get somewhere good. This project is a great example of that. When the design started to get more finished and needed feedback, what does an industrial design student at RISD really know about a kitchen? Not enough. So the experts were brought in. Julia Child came down from Cambridge and gave feedback on the different decisions. The series of studios generated thousands of innovative ideas. So I also should explain, I was not part of this project. I was not around when it happened. I've gone through the RISD archives and pulled out any of the images that were compelling and reorganized them according to the way I believe the story unfolded. I shared it with some people who were involved, and they said, yeah, that's sort of right. But I feel like the story is too compelling and the work too good to not share with you, even if I'm getting some of the narrative details wrong. There was a lot of blue sky thinking about smaller components. Forget about what the whole kitchen is. Let's look at every component separately. So there were ideas like a utility mouse, continuous wet surfaces, a pop-up dishwasher, a gray water irrigation system, a pre-washing system, countertop waste channels, a toe kick suction device, electronic consumption tracking, built-in retractable appliance cords, misting bays, steaming bays, retractable burners, a whole laundry list of features, because that's an important part of doing good design work. What are all the ideas possible? And then we'll go back and decide which ones are reasonable and not. But if you eliminate an idea because it's unreasonable, you might miss some component of it that is transformative. Ultimately, the designs were, as best as possible, collaged together, combined together, and run through the wringer several more times to arrive at final designs. This is a proposal that has a sort of a docking station. It has a cart that is part of the dishwasher, so you can wheel it to the table to set the table. You can put the dirty dishes from the table right in and wheel it back and plug it in to wash them. The top also raises for access to what's inside. The process of iteration went on for many semesters, working in cardboard to get volumes figured out, making prototypes for more sophisticated testing, and this was designed to work for short people, tall people, people in wheelchairs, people who were standing, people who were sitting. This is Michael Lai on the left and Mark Harrison on the right, actually testing things in a wheelchair to make sure that it would all work. And you can see many aspects of Christine Fredericks and Shuta Lahotsky's thinking in the decisions being made about this kitchen. There are bins for grains. The sink has adjustable heights, a pull-out ventilator, a pull-out light, and the models began to incorporate a variety of different combinations of the separate explorations. In the end, the universal kitchen was imagined as a kit of parts with interchangeable modular components for refrigeration, cooking, water delivery, and storage. So this is the pre-manufactured kitchen cabinet on steroids, because instead of having utilities you buy from one place and cabinets you buy from another and a contractor who puts it together, the whole experience is imagined as parts that fit together as one unified system. And it could be configured to suit your needs. It could be a lower kitchen, a taller kitchen, a kitchen with pull-out work surfaces and recombinable areas. In the end, the universal kitchen works for someone in a wheelchair, but it also works for someone standing who's tall, and someone standing who's short, and someone who just feels like sitting down while they wash the dishes. The goal is not to design to accommodate a disability. The goal of universal design is to design for all abilities, and it is a big task. The team went back and re-examined their initial spaghetti dinner with salad and bread, which originally had over 400 steps, that's on the left. When they ran that through the new design and the new layout of the universal kitchen, which they could do because they had built full-scale models, look how concentrated the number of steps became. Certainly, there are fewer than 400. I don't know the count on the final one, but even if they hadn't reduced the quantity, just by reconfiguring the organization of this, the clustering, in the same way that Lillian Gilbreth did with her Kitchen Practical, the kitchen becomes a better design. This is Jane Langmuir on the left, who was teaching in interior architecture at the time and worked with Mark to organize this effort. 2 prototypes were shown at the Cooper Hewitt in 1998 in a show called Unlimited by Design. And RISD ended up selling the exclusive rights to the Universal Kitchen project to the Maytag Corporation. It wasn't made for a long list of reasons as a finished design, but certainly it entered corporate consciousness at Maytag and elsewhere and influenced later design work. Many of the separate components that were involved in the Universal Kitchen were teased out and incorporated into other things. I love being able to show this work to students today because, one, it harkens back to an era before computers, or at the very beginning of computers, when design work really had to be done by hand, and there was a real benefit to that. You find your mistakes in a more meaningful way when you've actually built something. And 2, because it shows that all of the fancy CAD software that we have today isn't necessarily producing anything better. On the left is a model, a scale model of the Universal Kitchen. On the right is the prototype. This is the smaller component kitchen. And side by side, they look remarkably similar. So take that, all of you computer fanatics. Universal design, designing for all abilities, is incredibly important. And it's something that we now understand and strive to do in everything we're working on, but it was slow to arrive at a real conversation in produced objects. The Swedish group Ergonomy Designgruppen was one of the first companies trying to explore how things designed for all abilities could also be attractive, could also be manufactured, could be used by anyone, and could actually get out in the market. The whole focus on designing better tools to respond to and to fit our bodies continued to develop through the 70s. We'll look at this more throughout the rest of the semester, but I wanted to file some of the important steps forward in here this week because I think they fit really neatly into this sort of inevitable extension of scientific management, leading to an understanding of the psychology of efficient production, and then leading to designing for our own body's limitations. The trajectory there, I think, is a really neat and tidy one, and that's rare in telling the story of design history. I usually finish this week's lecture with enough time to include a spotlight on Eileen Gray. She has nothing to do with the rest of this week's content at all, totally separate chapter. She belongs in the Art Deco period that we looked at last week. She also belongs in the Bauhaus period and modernism that we're going to look at next week. I like to give her her own space because ultimately she existed outside of all the other eras and movements and ideas and just did her own badass thing. I have a full-length lecture on her already recorded on YouTube, so here's a link to that. You don't have to watch it, but I think you want to. If you don't want to race off and learn more about her, I can't help fix your life and your tragic lack of curiosity. As a teaser, the chair on the lower left, $28 million. The picture on the upper right, 98 years old. Forgotten, rediscovered, and becoming daily more important in the history of design and as we look in our rearview mirror in our decisions about what we want to remember and hold on to. So that's it. See you next week. Stop texting me while I'm recording. Why are you texting me? Why can't we have texting quarantine?